Okay, we're going to look at polynomial functions and determine if the given factor is an actual factor of the polynomial. And if it is, then we're going to be able to find all the real and non-real zeros of the function. So to determine if x minus 2 is a factor of that polynomial function, we're going to use synthetic division. So we put the 0 that would come from x minus 2. If we set that equal to 0 and solve for x, we would get 2. So that number would go in a half box when we're doing the synthetic division. And then we list out the coefficients next to it. So 4, -3, -8, 4. Leave some space and then put a horizontal line. Okay, now we're going to go through the process of synthetic division. And we bring down that first coefficient of 4 and multiply that result by that 0 of 2. So 2 times 4 we get 8, and that goes underneath the next coefficient. All right, now we add down -3 plus 8, we get a positive 5. Multiply 2 times 5, we get 10. That goes under the -8. Add down, we get positive 2. And then we take that 2 here and multiply by this 2, and we get a positive 4, and that goes here. Now, this last sum we get tells us whether we've got a factor or not. All right, if this is 0, it's a factor, and if it's not 0, then it is not a factor. So in this case, x minus 2 is not a factor of this polynomial function. All right, so we're not going to be able to use it to find any zeros. All right, let's try this one. So again, the 0 that we would get from the factor would be 2. And we list out coefficients, set up the synthetic division. So we always bring down that first coefficient. There's nothing to add to it. And then multiply it by the 2. We get a positive 6. Add down, we get 0. And now we multiply 0 times 2. We get 0. -5 plus 0, we get -5. 2 times -5, we get a -10. We add that down and we get 0. Okay, so since that equals 0, that tells us that x minus 2 is a factor of the polynomial. Okay, so what that means is that we could rewrite this polynomial, and I'm just going to label it f of x, as factors. So we know one of the factors is x minus 2. The other factor is going to be the quadratic that has these coefficients. Okay, so we get 3x squared. All right, there's no x term because there is a 0. Okay, so we skip the x term because that's what would go with this 0. And so since it's 0, there are 0 x's. And then we've got the -5 for the constant. Okay, so these are equivalent here. We can say this is f of x up here as well, and now we have written it in a partially factored form. Okay, now our goal is to find the zeros of the function. So remember that what we do is we set those factors equal to 0 and solve. So I'm just going to do that with these two factors. So x minus 2 equals 0. Well, we're going to get x equals 2. There is one of the zeros of the polynomial function. And then the other factor is a quadratic. And usually we have to use some kind of method like factoring or quadratic formula. But since we don't have that x term, we can actually just add the 5 to both sides, divide both sides by 3, and then take the square root of both sides. And if we take the square root, all right, we got to remember the plus or minus in front of the square root of 3/5, and we get x equals plus or minus square root of 3/5. All right, for our two other zeros. So there's 3 zeros of the function, 2 and positive square root 3/5 and negative square root 3/5. Okay, for this one, we are now not given a factor to try out. we want to use what we call the rational zero theorem to determine what possible rational zeros there are. And then from that list, use trial and error to find all the real and non-real zeros. Okay, so the rational zero theorem says that we're going to take, well, they call it P over Q, but P is factors of the constant term over factors of the leading coefficient. Okay, so we'll just start off by, in the numerator, we're going to take that negative 9 and think of all the factors that go into negative 9. So we've got plus or minus 1, plus or minus 9. Right, if we had 1 times a negative 9, we get negative 9. Negative 1 times 9, we get negative 9. And then the other possibilities are plus or minus 3. So plus 3 times negative 3, we get a negative 9. And then in the denominator, we're going to take that negative 5 and write down factors of negative 5. So we get plus or minus 1, plus or minus 5. Okay, that's going to give us a little bit of a list of possible rational zeros. So we're just going to take that plus or minus 1 up here and then put that over both possibilities from the denominator. So we get plus or minus 1 over itself, so plus or minus 1, plus or minus 1 over plus or minus 5, so we get plus or minus 1/5. And then let's do the same thing with the 9. Plus or minus 9 over plus or minus 1, we get plus or minus 9. And then we get plus or minus 9 over 5. And then same thing with the 3. Plus or minus 3, and then plus or minus 3/5. Okay, so what we have there are, we've got 6 times 2, 12 possible rational zeros. So here's where it is just trial and error with synthetic division. All right, so let's just start off with a negative 1. Okay, so I'm going to test out negative 1, see if it is a 0 or not of this function. So got to list out the coefficients of the polynomial. So we got negative 5 and then positive 16. There's a missing x term. It's important that we put in a 0 for any missing terms. Okay, so we're not just going to put that negative 9 after the 16. We are going to put a 0 in there to represent the coefficient that's on the x term. And since there isn't an x term, the coefficient is 0. And then we've got the negative 9. Okay, so going through synthetic division, all right, we add negative 5 to, there's nothing there, so it's just 0. Multiply negative 5 times negative 1, we get positive 5. We add down, we get 21. 21 times negative 1, we get negative 21. We add down, we get negative 21. And then doing the multiplication, we're going to get a positive 21. And if we add that down, we end up with a 12. Okay, so that is the number that tells us whether we have a 0 or not. Okay, that 12 is not equal to 0. So negative 1 is not, not a 0 of the function. Okay, so let's try 3. All right, so again, we're going to take negative 5, 16, 0, negative 9 as coefficients. Go through the synthetic division. And we do get 0. All right, so that tells us that 3 is a 0 of the function. Okay, so that we now can rewrite that function in partially factored form. So with that 0 of 3, that comes from a factor of x minus 3, right? Kind of think going backwards. If we have a factor of x minus 3, we set that equal to 0, solve for x, we end up with that 3. And then the other factor that we have is going to be the quadratic that has the coefficients of these numbers that we get to the left of that 0. So we get negative 5x squared plus 1x, or plus x, plus 3. Okay, so now our goal here is to find the zeros of the function. So we need to set both of those equal to 0, both those factors equal to 0. So we got x equals 3, right? There's that one. We already knew that one. And then we're going to need to either try to factor or use quadratic formula on our quadratic. So I don't think this is going to factor, so we'll use quadratic formula. So x equals -1 plus or minus 1 squared, or 1, and then minus 4 times a times c. So that's actually a minus 60. Or, I'm sorry, that should be a plus 60 because we have minus 4 times minus 5, so we get positive 20 times 3, we get 60. And all over 2 times -5, so -10. Okay, so we get x equals -1 plus or minus the square root of 61 over -10. All right, and those are our other two real zeros. Okay, so in this case, they are all real. Okay, we've got x minus 2, or I'm sorry, we got x equals 3. Okay, that's a rational 0. And then we have x equals -1 plus square root 61 over -10, and then -1 minus square root 61 over -10. Okay, those are both irrational, but real zeros.